Hi, welcome to Key Skill 5. We have already covered long division and the factor theorem. In the last section, there was a lot of exam questions, so I hope you've got all of those done in your workbook and that you've done all your key skill questions. If not, stop, go back and get all of those done before you proceed. In the last two sections, we've got 5 and 6 left to do. We're going to be covering the remainder theorem. What is it? How do we use it? How do we prove it? And what kind of questions can we expect? Before we get into that, in question 1, we're going to revise some key vocabulary. That's going to be dividend, divisor, quotient, and remainder. Okay, so what is the remainder when 24 is divided by 5? So 24 is a dividend, divided by 5 is a divisor. And the answer is 5 goes into 24 4 times, and it leaves over 4, okay? So state the remainder theorem. So now we're going to get into what is the remainder theorem. The remainder theorem states that if we have a polynomial f of x, okay, so we've got a polynomial f of x, when f of x is divided by, when f of x is divided by x minus a, we did that a lot. We've done a lot of long division where we've put a polynomial here and we've put x minus a, or we've put a factor here and we've done the long division. So f of x in this case is going to be what we're dividing, and x minus a is what we're dividing it by, okay? So when f of x is divided by x minus a, the remainder is f of a. So how would we calculate f of a? We can kind of think back to what we did in the factor theorem to see f of a would look something like this. For example, this is f of x. This is the function, the polynomial given in the question. We were asked to fully factorize, for example, x plus 5. We calculated that this would be a, and we substitute it in. So what the remainder theorem is telling us is if we want to calculate the remainder, we don't need to do the long division. We can simply plug in, or we can substitute a back into the f equation, and the answer will give us the remainder. Of course, if the remainder is 0, we know it's a factor, but we won't always be dealing with factors, okay? Now, how do we prove that? Okay, I'm gonna flash back to this example here. We have our f of x, our polynomial here, x minus a is our factor, and we put q of x up here, which is our quotient, plus r divided by x minus a. Let's go back to our let's go back to the questions that we've done before and have a look at an actual example of this. So here we go. In this example here, we did, this would be our f of x, this is what we divided. This would be our x minus a. And our answer is the quotient, so that's the q of x here, plus the remainder divided by x minus a. Remember, the remainder goes down here, okay? So how that's useful is you can say f of x divided by x minus a is equal to your quotient, which is what goes up here, plus your remainder, which we also divide by x minus a, okay? We can multiply everything by x minus a, and rewrite it in this form. F of x is equal to x minus a times by whatever your quotient was, plus your remainder. Now, if I substitute in here, if I want to think about what is the remainder, okay, I want to find out what is r. If I substitute a for x, so everywhere that I had x, I replace it with a, you can see that a minus a here would be 0. So I would have f of a is equal to r. This would be 0, so 0 times q of a, this would be gone. And I would have f of a equals to r. Now let's have a look at a practical example. Find the remainder when 2x cubed plus 4x squared minus 8x plus 5, so that would be your f of x, is divided by x minus 1, so that would be your x minus a. Verify your answer with long division. So we're going to do this both ways and check it works out. So here we go. This is f of x, 2x cubed plus 4x squared minus 8x plus 5. If x minus a is equal to x minus 1, we can see a is equal to 1. The other way that I usually do this is do x minus 1 equals to 0, x equals to 1. So here we go. F of 1 is equal to 2 times 1 cubed plus 4 times 1 squared minus 8 times 1 plus 5. So 1 cubed is 1, that would be 2, 2 times 1. 1 squared is 1 times 4, 8 times 1 plus 5. So 2 plus 4 is 6, minus 8 plus 5. 6 and 5 is 11, 11 minus 8 is 3. So let's see if we get exactly the same answer when we use the long division method. So 2x cubed plus 4x squared minus 8x plus 5. We're going to divide that by x minus 1. Okay, so here we've used the factor x minus 1, and here we've used the root x is equal to 1. I'm going to do this quite fast because we should be professionals at long division by now. Minus 1 times 2x squared, like that. Here we go, plus 4x squared double minus on the 2x squared. 4x squared plus 2x squared, bring down the minus 8x plus 6x minus 6x. That would leave me a remainder of minus 2x plus 5. Would divide, that would be minus 2. Minus 2x, that would be plus 2. Here we go. Subtract, and that would leave me a remainder of 3. So you can see that using the remainder theorem is much, much faster than doing the long divisions. If I was going to write this in the same notation that we've used in the proof, just so that you can see an actual example, I would say 2x cubed plus 4x squared, that's my f of x, minus 8x plus 5 divided by x minus 1 gave me an answer of 2x squared plus 6x minus 2 plus 3 divided by my divisor, which was x minus 1. Now, if I were to multiply both sides by x minus 1, that would be plus 3. So you could see if I let here x equals to 1, all of this would disappear. This would be 0. And then my remainder would be 3. So that's more or less how the proof goes. It's f of x is equal to the factor times by the quotient plus the remainder. And the second step is you just make x equals to a. Okay, let's move on to the next question. Find the remainder when 9x cubed plus 6x squared minus 18x plus 9 is divided by 3x minus 1. Okay. Let's start by finding our a. Then we just need to substitute that one in to our equation to calculate the remainder. So that should give us a remainder of 4. So that was f of a third, or f of a. And we check that really quickly with the long division. In the exam, it's not necessary to check with long division. I'm just showing you that you're going to get the same answer both ways, but one way is much quicker. There we go, exactly the same answer, remainder is 4. So that wraps up, I was going to say Rosa, but that wraps up key skill 5. You should now be able to prove or give a proof of the remainder theorem and use it to calculate simple remainders. In the next key skill, we're going to look at some more funky examples, but we're not really going to learn anything new. We're just going to look at applying this in some trickier or more different situations. I will see you in the next one. Bye for now.